Good afternoon, ladies and gentlemen. I'm your host for today. It's me, Talal, from my PV. The topic for today, as you might be familiar, is hot water and space heating from the PV system. So, the topic is gaining more and more traction day by day, and we will be going through this topic throughout this webinar of today. So, a short introduction about our team. So, on the left side, the guy, Dr. Gerhard Trimpler, is a co-founder for my PV. So, his experience with PV inverter side and also with the solar thermal. So, as a collective, that experience brought my PV into being. So, that's a idea from him. And yes, Reinhard has been with my PV more than 6 years now, and he has been involved in the training and as well as product management for our product. And from my side, my background is an electrical engineer, and more than about 3 years, I am handling the international sales at my PV. Moving forward, so we are relatively young company. So we started in 2011 as a, let's say, as a distributor company, but over the years since 2013 we changed our business model entirely to the manufacturing company. So we brought different products into the market: DC products, AC product, single phase product, three-phase product. So all these things will be discussed in the coming slides as well. Moving next is where we are. So we are an Austrian company in the province of Upper Austria, situated in the Neusäck. So this is the building which you are seeing in the slide. It's a sustainable building, or so to say, a passive building on a commercial scale level. So the building is covered with PV panels, and this is a pilot project where we show to the customers that uh, that utilizing PV power for heating is possible with energy efficient building. So take a look into it. When you need more details, you can ask me. Or the building itself has won several awards of the energy pricing. And yes, that's it. So moving next, I will give the handout to Reinhard. So Reinhard, take over and keep the webinar interested for us.
I will try my best, Talal. Thanks for the introduction. All right, ladies and gentlemen, welcome also from my side. It's about doing the transition to renewable energies. We want renewables, and we want to use it for all appliances, not only for our electric appliances, not only for power supply. We are also going to use it for EV charging, of course, but also for heat applications, for example, domestic hot water heating or electric space heating. And for these last two applications, MyPV offers the solutions. It's about power to heat applications. Let's take a look on a single family home. An average household, let's say an European household, I do not know where you are located, but an average European household with a third person size requires around about 4,000 kilowatt hours of power for electric appliances per year. And most of the people know about this value, but they hardly do not know how much energy they need for hot water heating. And coincidentally, it's nearly the same amount of energy when we are talking about a four-person household. So 4,000 kilowatt hours per year are used for hot water heating as well for a four-person household. And of course, your PV system can also cover this energy application to a huge amount during the year. And then it's about electric space heating later on as well. Therefore, you need to take a closer look on the energy efficiency standard of the building. It's not recommended to use electric heating, also when it's PV powered, for old buildings, let's say in Austria, my building where I'm living, requires around about 30,000 kilowatts hours per year for space heating. And this is the wrong building for our solution. But when we are building a building today, a new building according to modern standards, then also the requirement for electric space heating energy is that low. Then you can also provide PV power to a huge amount of the year for this application. For example, in our company building that you have seen during the introduction, where also in the facade PV panels are used, then this is the solution of choice where we can replace a conventional hydronic space heating system completely. But sorry, but for the time being, we start with hot water heating because this can be done always. It does not matter whether you're living in an old building or in a new building. Hot water heating by photovoltaics is always something you should take into consideration. Then it's about storage, energy storage. We have a fluctuating production of the PV system, that's clear. And when we want to store that energy, the excessive energy actually, then the battery storage or ESS systems come into our minds. And that's clear because we have electric energy now. We want to store it electrically and we want to discharge it electrically. But storage capacities of stationary battery systems, they are, let's say, somehow small. I'm talking about 5 to 10 kilowatt hours of battery capacity in a single family home. On the other hand, we can focus on our hot water boiler and see there, when we heat up a 300-liter hot water boiler, let's say for 45 degrees centigrade, then we can store 15 kilowatt hours of energy there. Of course, now it's heat. We cannot get back electricity out of it. We cannot reverse the laws of physics, but it's storage capacity that is already in your building where you're living. And with the MyPV technology, you can make use of this storage capacity for your PV array. And this can be a cheap alternative to a stationary battery. Yeah, that's clear. But it's a fact that MyPV does not compete with stationary battery systems. There's a huge number of compatible manufacturers where you can combine both storage technologies together. Here is a rough overview of our portfolio. Our history began, as a manufacturer, it began 10 years ago with a product named ELWA. The abbreviation ELWA just means electric water heater. That's what it's all about. And the product with the gray cover is the only DC solution we have. So there are PV panels directly connected to the units. There is no PV inverter in between. Somehow this means that you have the same principle as when you're using a solar thermal system. You take all the energy from the roof and you use it for hot water heating only. You cannot use this electric power for other appliances in the building, for example, the light or the TV or whatever. You are using everything of this power for heating only. But now you have wires instead of pipes. And in doing so, you make the heat production, the hot water heating out of the energy from the sun many times easier than with a conventional system. And nowadays it's also cheaper. And when a technology becomes easier and cheaper, then it's replacing a conventional technology for sure. And this is what happened during the last years. And there is a huge amount of advantages there. You do not have a pump, you do not have valves, you do not have to do the piping. There is no anti-freezing liquid you need to maintain. You just plug in DC plus and DC minus, and that's it. You do not even need a permission from the grid operator to run ELWA because it's not grid connected. And I'm going to show you a model of ELWA now. And you see there are really the DC plugs, multi-contact plugs on the bottom here. And there's also a mains plug, but it's not necessary to use this mains plug. It's an option for backup. While the DC power output on the heating rod is linearly controlled by the ELWA, between 0 and 2000 watt, you can also make use of this additional power plug, which means 750 watts additionally AC power from the socket if you want to use it. It's not a requirement. We have customers who have never ever used it. And this means that ELWA is supplying itself with power from the DC side as well. And that means it also works during a blackout, and it also works in remote off-grid systems. And here is a typical Austrian building. Let's say it's from the 80s. And in this building, the ELWA system was used for the first time in the year 2014. There it replaced a conventional solar thermal system with flat plate collectors. And this ELWA unit is also, let's say, overpowered. So the DC input voltage on the unit has to be in between 100 and 360 volts. And while the power output is limited to 2 kilowatts, you can also connect more than 2 kilowatt peaks to the unit. It does not matter as long as you do not exceed this maximum DC input voltage of 360 volts. Yeah, this guy, the owner of the building, was, of course, asked by my colleagues, what do you think about the ELWA? Because he knew the conventional system. And he said, well, he likes it the most during cloudy days or on cloudy days. And this sounded a little bit confusing in the first time, but then he explained this to us. He meant a solar thermal system does not work when there is indirect sunlight. It does not work when there are clouds on the sky, but a PV system does. Of course, it works with a lower power output, that's clear, but it works. And that's the difference. And when on the average, the ELWA works with, let's say, 250 watts because it's bad weather, then you also have provided the hot water energy demand for one person on a day where a conventional solar thermal system would not work at all. And that's the coolest thing on photovoltaics. It's always working, and we make use of this for this power to heat application as well. Yeah, on this image here, there's also an accessory part. It's an infrared connector to download the data from the internal data logger. As I said, the product is now 10 years old. Nowadays this would be a Wi-Fi access point or a Bluetooth access point or whatever. 10 years ago it was an infrared interface, but it's not necessary to buy this interface to do the commissioning. It's just an accessory part. All right, benefits. This optional boost backup with the mains plug is a patented function, and during summertime you can use it also during, let's say, a bad weather period of 2 or 3 days, and that means you can switch off your conventional heating system completely during the summertime. And how much solar coverage can you expect of ELWA? Back again, let's think about a 4-person household. Then you can expect a coverage during the year of 50%. I'm talking about Central European climate conditions and irradiation conditions. Of course, it's different on other locations in the world. And therefore, we have an online calculator to do a calculation for your spot. But for Central Europe, 4-person household, ELWA does around about 50% of the hot water heating during the year. Nearly 100% during summertime. In wintertime, of course, it's much lower, much less. On the average during the year, 50% for a single family home. And there are also some technical specs here. As Talal said during the introduction, we are going to send you the slides after the webinar, and you can go through slides like this with a very high density of information later on if you like. Okay, ELWA. It was the only DC solution we have developed so far. It's the only DC solution in our portfolio. All I'm going to talk from now on forward means AC solutions. We are now on the grid. There is a PV inverter in the system. And of course, this PV power supplies the electric loads in the building with priority before the power to heat application by my PV. But why does it make sense not to feed in surplus into the electric grid? Of course, it's about energy independence. So keeping the energy for our own means more autonomous rate, more autarkic rate. Then there can also be an economic reason. For example, when the feed-in tariff is lower, respective the energy price that you get when you feed into the power grid is lower than the price for the kilowatt hour of your conventional heating system, then it's immediately wise to keep this kilowatt hour in your building, use it for heating, and replace your conventional energy system. Let's say gas or oil or whatever you are using for heating. It's replaced one by one. And there's also a technical reason. It's about grid stability. When we avoid feeding into the grid, also the grid is not that much overwhelmed with power during summertime. And here again is described graphically what we are using in the end. So the PV power supplies the building. When there is a stationary battery, also the stationary battery is charged with a higher priority than the MyPV application. And before the energy is fed into the power grid, we make use of this excessive energy. And therefore, you need to meter this energy surplus somehow in the feed-in point. Actually, it does not matter for us how much power the PV inverter is producing. It's about the surplus power in the feed-in point. And this is where our information comes from. Actually, there can also be a wind turbine on the other end, or a small water system, whatever. We are measuring in the feed-in point and make use of this excessive power. And one way to detect this excessive energy is a meter named MyPV Wi-Fi meter. It is installed in the feed-in point next to the utility meter of your energy supplier. And with 3 small CT clamps, current transducers, it's very comfortable to install this meter in the feed-in point. You just clamp it on. And off the shelf, it comes with 75 amp CT transducers, but upon request, we can also provide bigger CT clamps up to 600 amps are possible from MyPV. And while the Wi-Fi meter is installed in the feed-in point, the other MyPV device is installed in the boiler room or in the installation room of the building, and it receives the information how much excessive energy is available from the meter in the feed-in point. And therefore, we're always using LAN, respective Wi-Fi. This meter does not need to be used in every case. For example, there is another system that does the metering in the feed-in point instead. And MyPV's philosophy is to be open for third-party control. And that means when your inverter or your battery manufacturer has already a meter in the feed-in point and we can make use of this signal, then it's not required to install the Wi-Fi meter additionally. Then we use the signal from one of those. It can also be a smart home system. We provide the communication description of our devices to you if you like. Just send a short email to Talal or me and we are sending it over to you. And then you can control an actor, for example, with your own home automation system. All right, so now we measure the excessive power in the feed-in point somehow, either by us or by a third-party system. First way to make use of this excessive energy for heating is a product named AC ELWA-2. And currently we are replacing the predecessor named AC ELWA-E. E is for Ethernet, and AC, of course, means alternating current. We are not directly connected to the panels. We are taking the power we are using for heating from the AC building installation. It has a separate circuit, and it's a normal AC circuit in the building. But we are using just as much energy as is available as excessive energy. So this varies. And here we see again why it's so important to adjust the power output. Finally, this is what MyPV is developing. We are developing and producing AC power controllers. And we are using our power controllers to adjust the output power on the immersion heater, for example. And that's so important because two things are changing permanently. PV power is changing, that's clear. Clouds are moving on the sky and so on. But also the loads in the building are changing. Something is always switched on and off, and it's about the difference. It's about the saldo in the feed-in point. It's about the amount of energy which is too much in the building. And to make the balance in the feed-in point very fast and very accurate to avoid input to the grid or input from the grid or feeding into the grid, we need to adjust our power output accordingly. And how fast this control happens between the signal source and the AC ELWA-2 actually depends on the signal source. It's not the same for all of those types. The very fastest way and most accurate one is, of course, controlling it by our own meter, which means 1 time per second for each single watt, the power output of AC ELWA-2 is adjusted. And when you just switch on the light here in the living room, we immediately decrease our power output here to ensure the balance in the feed-in point once again. And this happens again and again and again from 1 second to the other. All right. In direct comparison with AC ELWA-E, there are 4 main advantages. Number 1, while AC ELWA-E was a 3 kilowatt unit, AC ELWA-2 is now a 3.5 kilowatt unit, and this means 17% more power available. And then it's obvious, you see it, there's a color touch display on the device. And this is a solution we reused from the Actor product. We are going to introduce it later on. And this display here on the Actor, it works so perfectly since 2017 already that it was so clear that we are reusing the display also for the AC ELWA-2. It's a very intuitive way to do the settings on the device. For the commissioning, it's very easy. And while AC ELWA-2 received the excessive power information via local area network, respective via Ethernet only, you have the option for Wi-Fi as well with the AC ELWA-2. And if you can set up a Wi-Fi connection with a stable Wi-Fi connection, of course, it's not necessary to install an Ethernet cable then. But this is optional. Of course, on the bottom of the unit, there is also an Ethernet connection available. We think we need this because when we imagine where this system can be installed, it's about the basement in the building between the unit and the signal source. There can be a level of concrete in between or something that makes the Wi-Fi connection unstable. And that's why it's optional also with Ethernet as in the past. Okay, and then we have something that means a separation of the craftsman, let's call it that way. For AC ELWA-E and ELWA right now, it's somehow a problem in some cases that the plumber and the electrician work together on one device. And that's why we decided to separate the AC ELWA-2 when it comes into the box, into 2 parts. There's the immersion heater, the heating rod, separated from the control unit. And this means that the plumber can assemble the immersion heater in the tank. He checks the ceiling and he refills the tank. And later on, maybe the electrician comes, sets on the power stage of MyPV and connects it with the signal source. This can be a scenario, and it's definitely much more attractive than the AC ELWA-E to install it. All right, there's also a product video where we are also showing this separate way to install it. We are not going to look at the video now, but when you get the slides later on, you can click on that link and see the YouTube video. It's very short, 1 minute and 40 seconds. Just go through it. I want to recommend it to you. And there are much more options now to receive the signal. While AC ELWA-E was limited to Ethernet, we have also Wi-Fi, I already mentioned that, but there is now also RS485 available on the device. And so we closed the gap to the actor, because the actor was always able to receive it via Ethernet or RS485, and now also AC ELWA is able to do so. And by the way, you can also give the unit the set point signal by a PWM signal or by the AC frequency later on. This is not available for the very first batch, but as for the actor, it is planned that you can control AC ELWA-2 also by the frequency. Frequency control is only relevant in off-grid systems. So in mountain shelters or somewhere out in the desert where you have a battery inverter which can do the frequency shifting, there comes this communication principle into the game. All right. Benefits. I think I also already mentioned that. One thing that is important to know for both units, ELWA and AC ELWA-2, it is possible to install them in hot water boilers or in storage tanks. In storage tanks, they can also support a hydronic space heating system if you like. The only thing you have to consider is that we recommend not to go above 60 degrees centigrade when it's in contact with fresh water in hot water boilers, because calcification can also be an issue for our immersion heaters. As always, in space heating water in a storage tank, it does not matter. You can go up with the target temperature to the maximum if you like, and support the hydronic space heating as much as possible. All right, technical details. I'm going to skip that slide. Here is another project example that's working with AC ELWA-E. It's a 10 kilowatt peak system, and while AC ELWA-E has a maximum power output of 3 kilowatts, it was possible to increase the self-utilization ratio, the self-consumption, from 30 to 75%. And of course, this will be better with AC ELWA-2 because we have now a 3.5 kilowatt unit. And of course, it would also be possible to use more of these immersion heaters in one tank as long as you have the connection threads available. The multi-mode, as we call it, is possible. And then this self-consumption ratio would increase even higher with more than one unit. All right, how much self-consumption improvement can you expect? Here we are using a diagram of the Technical University of Berlin. These are not the MyPV numbers you see here. And for a single family home with a 5 kilowatt peak system, the university described that there is around about 1/3 of self-consumption ratio possible. The rest of the energy goes back to the grid. And to improve this, you can install a stationary battery. That's one way to do an improvement. Now you have a self-utilization ratio of more than 60%. So it's twice or 2 times that you had before, but you have to accept a huge amount of investment. Alternatively, you can use an AC ELWA-2 and see there you increase your self-utilization ratio even higher at lower investment in comparison to the stationary battery. But once again, we do not compete with the batteries. And when you use both systems together, you can expect more than 90% of self-utilization ratio for this example here. And if there is a battery, the battery should have priority before our application. Why is that? It's easy to explain. Once it is heat in the hot water boiler by our device, we cannot get back electricity. So again, we cannot reverse the laws of physics. And electric energy has a higher value than heat. And that's why our application has a lower priority. But now we have the beginning of July, and right now we see very much that somehow during the late morning, the battery already is on the state of full charge. And when it's on SOC 100%, it means that we have plenty of excessive power available for the rest of the day to do the hot water heating. The worst thing that can happen to your PV system is that the power output of the inverter is decreased. Worst thing that can happen when we are thinking about the transition to renewable energy. So what can we do? We make use of additional storage capacities. Keep the energy for your own in the building and keep the power output of your inverter high. Okay. And here is the online calculator I was mentioning before. It's free to use. You do not have to register on our website. Just use it. You can do the configuration of your system. You can also do a calculation of your operational costs if you like. And you can calculate some variance to compare what setup is the best for you or your customer. I really want to recommend it to you. It gives you the background to do your sales activity, to do your consultancy on the customer, because the customers want to know how much they can expect. They want to have hard numbers, and this is the tool that can provide this. All right, ACTHOR. Now imagine you already have an immersion heater in your tank. Then you cannot, or you probably don't want to use AC ELWA-E. So what is then the question? Can we just use the power stage without the immersion heater of AC ELWA-2? Yes, we can. And the product, therefore, is called ACTHOR. And this is the power stage only. Instead of the immersion heater, it has a main socket. And on this main socket, you can connect a standard electrical heater. It means an ohmic load. It does not work with a heat pump. And please do not connect your EV charging station. Somehow this question comes again and again. It's for resistive loads only. Okay? Immersion heaters, infrared panels, electric heating mats. And when you connect one of those here, this electric heater now becomes PV ready. What does it mean? It means that the ACTHOR is doing the adjustment of the power output like a gearbox. Yeah, now this heating output is adjusted from 1 second to the other. It is changed according to the amount of excessive power, and it comes in a single phase variant, 3 kilowatt maximum, and the ACTHOR comes also in a 3-phase variant, 9 kilowatt maximum. Okay, there are 7 predefined operation modes. These are somehow standard modes. Most of the projects can be done by one of these presets. The most important one is this mode 1. It's let's say for a 9 kilowatt immersion heater for the ACTHOR 9S, and this means in an installation like this, you can use most of the energy for your own. You can connect a 9 kilowatt heater or also a 6 kilowatt heater or a 4.5 kilowatt heater to the ACTHOR 9S, and it will detect the nominal power of this load automatically. And up to 9 kilowatts are possible. And when you assemble such a heater at the bottom of the tank, it means that you have the whole volume available for heating. This means high self-consumption ratio. The disadvantage on the other side is that it might take a long time to heat up the whole volume. Maybe you do not reach the target temperature during the evening. So for the ACTHOR 9S, there is another way to do this heating. Instead of one 9 kilowatt heater or 6 or 4.5 kilowatt heater, you can use 3 single-phase heaters. Up to 3 kilowatt maximum are possible per ACTHOR 9S output. And when we assume that we have 1 kilowatt of excessive power available here, then the immersion heater on the top is linearly power controlled. Due to the smaller volume of the heater, it means that you are on set point or on target temperature much faster than with a 9 kilowatt heater at the bottom. And now let's assume you have 4 kilowatt of excessive power available. Then the heater on the top is switched with nominal power to maximum, and the ACTHOR 9S does the linear control with the heater in the middle. And now assume that we have 7 kilowatt peak, 7 kilowatt excessive power available. How does it work then? The heat on the top and in the middle are switched with nominal power, and the heater at the bottom is controlled linearly. Overall, up to 9 kilowatt are possible maximum, and this happens as long as the thermostats on the heaters are on. When the heat on the top is on target temperature, the thermostat disconnects the load from the Actor 9S, and the Actor continues working with the other remaining immersion heaters. So I skipped a few slides. I'm going to scroll back here. For the Actor and the Actor 9S, there are the same ways for the communication available as with the AC ELWA-E. So this is more or less the same list as you know from before. Technical details, there is one thing I want to mention for the Actor 9S. When you connect an ohmic load, an electric heating element to the unit, it needs to have a neutral conductor. The Actor 9S is connected in a star connection. It's not working in a delta connection. And due to this neutral conductor, it is available to detect the nominal power of its load automatically. So this also works for the single phase variant. You can also connect 1.5 kilowatt, 2 kilowatt immersion heaters, does not matter. The units are available to detect this by themselves, and you do not even have to change a setting to operate the unit then. When you want to be sure that all components fit together, you can also use accessory parts from MyPV. There is a 3 kilowatt single phase heater, a 3-phase 9 kilowatt heater for the Actor 9S available in our program. But actually it also works with heaters from third-party manufacturers. This is just, these are accessory parts from MyPV here. All right, so far we always talked about immersion heaters. It does not matter if you use them in the hot water boiler to do the freshwater heating or in a storage tank to supply your hydronic space heating system. Now I want to start a new chapter. Now it's about doing the space heating as well in an electrical way. And now remind of this diagram at the beginning. It's the wrong technology for old buildings. When we are building a building today, according to modern energy standards, it's different. There we can replace the hydronic system for the space heating as well. And in doing so, the building installation becomes easier, becomes cheaper. To make this whole story interesting, you need two things. Two things need to be required. It's a low energy building. It's not a passive house, but nearly passive house. And number two, this building is completely covered with PV panels on the roof. You have seen the image of our company building at the beginning. Even in the facade, we installed PV panels there. So low energy building standard and a huge PV system. And then you can also contribute to your electric space heating as well, even during winter time. When we compare this with the state of the art, then we need to talk about heat pumps. And the heat pump has something that is so-called seasonal performance factor. And this is more or less a number of 3. Sometimes you hear higher numbers, 4 or more than that. Let's say 3 on the average. And this means that the power drive in the heat pump is electrically driven, that's clear, but it also uses energy from the environment. And the factor of thermal output in comparison to electric input is 3. So the energy from the environment comes from the ambient air. The ambient air is heated by the sun. And this factor, seasonal performance factor, is more or less stable. It cannot be changed by the customer. And now let's think about a pure electric system that is powered from photovoltaics. And then we see, we are using the same energy source here. It's the sun as well. What changes is the energy carrier. It's not about a cooling liquid that needs to be evaporated somehow and needs to be compressed. It's now just electrically. That's it. And the installation is now with wires instead of pipes, and it's many times easier and cheaper. And when the PV system is big enough and when it covers the whole roof, then the seasonal performance factor here can be better than with a heat pump. So the heat pump uses the evaporator to get environmental energy into the building. We are using the PV array to get environmental energy into the building. And it's now easier and cheaper. And when at the end of the year, in the energy balance, this kind of system required less energy from the public grid than the comparison variant with the heat pump, then it's also greener. Then an electric heating system becomes greener than a heat pump system. And this is something new. You have to think about this. We already did, and we have done such projects. This is an example here in Austria. Single family home, 11 kilowatt peaks on the roof. And at the end, the costs to operate this building were by 750 euros. And this included not only the electric demand for appliances, also hot water heating and electric space heating was covered. For this user, it was much cheaper. He saved on the boiler room with all the piping. He saves on operational costs, and he saves on the boiler room itself. There is no building installation room in this house. All the components were in a small chamber. There's the hot water boiler, the inverter from the PV system, and the Acto 9S, which makes the electric heating system PV ready. All right. You can use more than one of those in one and the same Ethernet network. Up to 11 devices are possible, and therefore it's also very interesting for residential construction. When you think about one actor for each apartment, you can also put the hot water boiler inside the apartment. And this means you avoid all the distribution losses, the thermal distribution losses on ring mains. By putting the boiler back into the apartment, the system become much more efficient than heating up a tank somewhere in the basement and do the piping to the apartments. Okay. And then there is this way to use it in off-grid systems. I talked about frequency mode. So in a pure off-grid system, you can also adjust the AC frequency. And practically, one of those is doing the adjustment. So it's about a battery inverter, like one from SMA, from Studer or Victron, and they increase the AC frequency when their battery becomes full. And they do so to tell the PV inverter he needs to deactivate or decrease the power output because the battery gets full. What we are doing is listening on the AC line to this frequency increase, and we use this as a set point signal for the power output. In that way, we use excessive energy that would be wasted completely otherwise. So the PV inverter would decrease the power output, but not when we can use this energy instead for hot water heating, for example. And there are some cool projects already here, a typical Austrian mountain shelter project, but there's also a remote project in Australia, Western Australia. There's an avocado farm where we do the hot water heating to washing to heat the water for the fruits that are washed. And the coolest one is this on the bottom right. It's a Belgium research station on the South Pole. So there is plenty of excessive power available there, not only by the PV array, but also from the wind turbines. And for us, it does not matter where this renewable energy comes from. It just matters that it's excessive energy and we can make use of this. So there are two screenshots from the MyPV data cloud. These are not up to date because last weekend we switched to our new cloud. But at the end, it's about the same idea. You can remote control our devices. You have remote access to the units on the customer's place. You see how this devices perform, and if you want to change some settings, you can do this from your office without going on site. Okay, there is plenty of information available on our website, which means wiring diagrams are available at any time. You do not have to wait for the first delivery to take a look on the manual. You can download this anytime without a registration. We are also uploading short videos on YouTube regularly. Probably there are some interesting info videos there for you as well. And finally, I want to end by saying power to heat is the cheapest and easiest way to improve your self-consumption ratio, because the storage capacity we make use of is already there. There is already a hot water boiler, and with the MyPV technology, you can make use of this storage capacity for the PV system as well. Where to buy? Talal already mentioned his email address here in the chat. You also find a list of our distribution partners on the website. And finally, I want to thank you very much, ladies and gentlemen, for your time. Talal, as far as I have seen, there is no question left. If you want to switch on your camera, you can also say goodbye to our listeners if you like.
Okay, over and out from my side. Good afternoon. Stay healthy and stay safe. Bye.
Empowering the solar future.